What's going on YouTube? This is Ipsec. I'm doing Forgot from HackTheBox, and I absolutely love the foothold of this box because it taught me a whole new attack category, and that is the web cache deception attack. Before this, I've never really used it before. I kind of heard of it, but I didn't really understand the impact of it. Essentially, we get an admin to navigate to a page that gets cached on a server, so then all other users that access that web server during the time period of it being cached can access that page, so we can see what the admin saw, which could be sensitive data. But before we do that, we have to log into the application as a low privilege user, and we can gain that access by doing a host header injection in a password reset of the application, which means we reset that user's password, and the link that gets emailed to them points to our server instead of the legitimate server. So whenever something clicks on it, they go to our server and we can steal their password reset token. And then the root step is attacking a TensorFlow library. So let's just get into it. As always, I'm going to start off with an nmap. So -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it forgot. Then the IP address of 10.10.11.188. This can take some time to run, so I've already ran it. Looking at the results, we have just two ports open. The first one is SSH on port 22, and we can tell it's an Ubuntu server. We also have HTTP on port 80. It's running WorkZug, which is just a Python web server. We can see Python here. And since nmap doesn't fully identify this as a web server, it gives us the entire HTTP request where we can see it was a not found. There's the server header, but the interesting thing is this Varnish piece. This is definitely not standard. We can see x-varnish 10, age 0, and via 1.1 varnish 6.2. So if we Google like Varnish and then web server and click on introduction to Varnish, we can see it's a caching HTTP reverse proxy. So it helps speed up pages by just caching the response so it doesn't keep having to execute code on its end to build the web page. We'll get into more of that in a little bit, but right now let's just take a look at the web page. So 10.10.11.188. And we get a login form. So the very first thing I do is like admin password and see invalid credentials. So now let's try a different username, one that definitely doesn't exist. We'll do that, right? And it still says invalid credentials. So we can't enumerate valid usernames. There is a forgot password thing here. But before I go to that, I just want to identify what type of technology this could be. The easiest way is to hit a 404 page generally, and we see this string, and this is relatively specific to Flask. If we just Google it, we can see Flask is everywhere on this result. So chances are we have a Flask web page. It's definitely backed up that's Flask because it's WorkZug. I guess it could be a different Python server like the HTTP server, Django, things like that. But this is definitely going to be Flask. So let's take a look at running some recon in the background. I'm going to do gobuster dir -u http 10.10.11.188 word list opt seclist discovery web content raft small words .text, and the out file will be root.gobuster. So while that's running, let's see if we can enumerate potential users of the box. So I'm going to click on forgot password, and then we're going to put a username. I'm going to do admin, right? And we're going to see admin password can't be reset. So let's try a username of please subscribe to see what this says. If it says invalid user or gives us a token or something. So invalid username. Chances are we can validate potential users. We just don't know anything else. We know admin exists because we can't reset it. And we also know that please subscribe gives invalid user. So what I'm going to do here is an admin, and then we'll comment this out just to see if we have some type of SQL injection. And we get invalid username, so it doesn't say cannot be reset, so it's treating this as a separate user. I'm going to put a parenthesis on it because that's sometimes common. And we're just trying to get it to say admin cannot be reset, right? We could do a double quote. We can get rid of the quote, and everything we do triggers invalid username, not admin can't be reset. So I don't think this is SQL injectable. So what we have to do is figure out potential usernames on this box. If we go back to the GoBuster, we have a /home. So we can check that out. I'm guessing /login is where we're at, right? So I'm going to go to home, directs us to login. We have /tickets. So let's check out tickets. Still nothing. And there is /reset. I'm guessing this is where we can reset things. And it says set new password. So I'm just going to do password and see what happens here. Click save, and we get invalid token. So chances are we need something here to reset the password. I don't see a field for token. We could like add it ourselves. So like $tokens is equal to please subscribe. And then if we do password, do save, we get invalid token. I think that's what we got before as well. I'm just going to go over to Burpsuite real quick. And I want to see if we hit save, does it send the token here? So the token is in the URL when we do this. So we don't know what a valid token is. I'm guessing we need some type of username still. So let's take a look at the page source. And okay, I thought it said password. I thought like we cached the forgot password page and replaced the index. But scrolling around the page source, we do see Q1 release fix by Robert-dev. So I'm going to copy this entire thing, go to the forgot password. I'm going to try resetting Robert. And let's see what happens. Invalid username. We can try Robert-dev. And see what this says. Still invalid username. So let's try the entire thing. Robert-dev 10090. Click reset. And we get a password link has been sent to user inbox. Please use the link to reset your password. So we don't have really anything that indicates there's a mail server here. Only port 22 and 80 were open. There's nothing really else. One thing we could do is test for forging mail headers. So I'm going to do one other test before we do this. And this isn't needed. This is just like one way to kind of identify how a web page is doing it. So what happened when we got to tickets? Tickets redirected us, right? We get location is equal to /. So what if I change this host? So if we do 1, 2, 3, 4, we still get location is equal to /. But this could be, oh no, it's not cache because the age is 0. If we start seeing that age increment, then we know that we're getting a cache page because that's how long the page is in seconds. What if we went to /home? There we go. So on /home, the location header does get set. And if we put something else here, so we can do 10, 10, 14, 8, we can see the location gets set this way. And what this is telling us is the web server dev is starting to trust the host header of a HTTP request instead of using the default like server, which should be like an environment variable or something hard-coded. You should never really let the user dictate on the location. And as a result of that, if we reset this request and start up our own web server, so I'm going to do sudo nclvnp80, and we're going to intercept the reset request. Let's see, turn that off on. I don't know what that is. Let's go forgot password. And then Robert-dev, I forget what that user was, 10090. Like that. So let's intercept this. And we're going to set my IP address to 14.8, right? And when this emails the user a reset link, there is a chance that they click on it and it forwards it back to our box because the web server, if it's doing the using the host header as part of the link, then it adds that because essentially the web server is going to pick the server and say, okay, here's the link, http 10.10.14.8/token, and then some random link, right? That is what we're testing here. So we still have something listening on 80. And give this a few seconds to see if anything comes in. 10.10.14.8, that is my IP address. And there we go. We have a click, so we can copy this, go back to our browser, turn intercept off. And when we go to this page, the reset, we can set a password. So we'll do password of password, click save. And now let's try logging in. So let's go to /login and we can copy the username. So robertdev190. And then put a password of password. And when we log in, we get logged in as Robert. So I know this probably seems like black magic. I'm going to pause the video. We're going to get root and explain what just happened. Before we get too in depth, I just wanted to show how common it is. So this is just a Google search on host header injection password reset, and we can see tons of things talking about it. Things as recent as 2023, as old as 2017. I'm sure it goes farther back than 2017 as well. Essentially, the vulnerability is when the server trusts the host header. And there's two ways you can really test for it. I'm sure if we went to OWASP, it would tell us. But most common in WordPress, this was vulnerable because it would change the from. I don't think it would change the actual link that gets sent, but it would change the domain it is from. And when it did that, you could control what gets passed into the mail library and get code execution on the server that way. The other thing that could be vulnerable is if it changes the way the link is built. And that's how this one works. So if we look at the code, we can see this is the code for forgot. And right here is where it's building the link that it emails the user. And instead of getting it from like an environment variable or something like that, it's going to get it from the request header host. And in legitimate things, this is going to be the correct value. It's either going to be like forgot.htb or something, because that's how the user gets to your web page. So that's why developers may do it. However, the issue with this is we poison this. So now the link goes, instead of something legitimate, we put it to our web server. And that way, when anything clicks that link, instead of going to the legitimate server of forgot.htb, they go to us. And when they go to us, we get the token to reset their account. And I know what you're probably thinking now. Well, someone has to click that link. No one's going to click a link that they don't really expect. Well, that's not true, because people click links they don't expect all the time. However, that doesn't even matter in this case, because other things click links too. Bots love links, especially like mail filters, because they got to examine the link to identify if something is malicious. And we can prove that very easily by just standing up a web server, sending a link in email, and seeing if anything gets clicked. The easiest way for me to stand up a web server is just to use Burpsuite Collaborator, which is a paid thing. I'm going to copy 3 links to my clipboard, and we can show what it does real quick. So if I just do v payloads, we got 3 different ones, right? And if I copy this, we can just do a ping real quick. So I'll ping this, and then in a few seconds, we're going to see interactions. And it's probably going to be a DNS one because it doesn't have ping enabled. If I just do poll now, there we go. We have 3 different DNS requests that all just went to this one thing, right? So I'm going to get a different URL, and we're going to email an Office 365 email. I found Office 365 loves clicking links. I did it to my Google. It didn't click a link, but I may not have the mail filter set up correctly. So let us go over here and let's create a link. And in this link, we're going to say login here and point it to this address. We'll do HTTP. And then I guess reset question token is equal to please subscribe. And I'm doing this so we can validate that the bot sent all the variables, right? This is a pretty good test. So now I have just sent it. And let us go back to Burpsuite, and we can just wait for the request to come in. And there we go. We have a lot. So let's take a look at this. Here's an HTTP request to this. And if we look, we do have it saying it. It also says like the host header and what the host thing is. We can look at all of these. It was trying to get the fave icon. So I guess it does kind of a, oh no, this is part of the thing. The referral is down here, right? And we can prove this is not me, right? Because we see the IP address here. So if I just do maxmind.com, let's see, I can't copy that IP address, so we will type it. So let's do 66.66.206.29.215. And we see this is some data center, I guess. We could try the other one where it got fave icon, so 94.35.54 right here, submit, and this is definitely Azure. So Azure is requesting the fave icon and sending the token. So if the server was vulnerable to this, the user doesn't even have to click it because the mail filter clicked it for us and sent the token to the adversary. So that is why the host header injection is such a severe vulnerability, and it's super easy to test for. Again, just go to the password reset, send yourself a mail, intercept it, attempt to change the host header, and see if the domain it's from changes or the link itself sends you to a different server. So hope that clears things up. We can get back into doing the box now. Okay, now let's get back to pwning this box. We logged in as the Robert user, and we did that by resetting the account robert-dev-00090, I think it was for us. I think that number changes based upon the IP address you are. So the IP address username is going to always change. Let's just take a look at what we can do. There is a search thing up here, and typing it, it doesn't look like that did anything. Let's intercept that in Burpsuite and see what happens. So turn intercept on, click send, enter. Let's see. It just does a get on home. So that literally does nothing. If we go to tickets, we can see there are 4 tickets. This one getting an error while accessing search. So I guess that's what we just did. It's a work in progress. They're pending a pull request merge. User privilege is not approved when requested, and SSH credentials. Now, this one is the interesting one to me because it says SSH credentials in the issue. So maybe in the details, we have it, right? If we click on escalate, we can see there's a link, a reason, nothing really else. I can't click tickets escalated. So I'm going to go over here, see if I can inspect this and see what this goes to. So if I click on navbar, we see it is disabled and it goes to /admin_tickets. So we can either re-enable it or just do it ourselves. So admin_tickets. And we get home is equal to access denied. So it just goes back to the page. The other thing I want to test right now is how to get access to these tickets. So maybe there's a tickets ? ID is equal to 1. And we just get back to the support page, maybe ticket/1. And again, we're getting back to this page. If I do ticket/please/subscribe, we get back to this page. So everything on /tickets keeps redirecting us to the same thing. And keep in mind, Varnish caching was being used on this, right? So if I click intercept on, I don't know why it's loading HubSpot. That is odd. I guess there's a HubSpot JavaScript somewhere here. Turn intercept off, turn it on. Let's see. How do I disable that? I guess confirm that it is going from this page. I only have 2 things open, I think. Yeah, I don't have Firefox open elsewhere. If I reload this, it's making a lot of requests. So yeah, this is the page. It is going to HubSpot. So what we should do is go into my proxy settings and let's see, request interception rules. Let's click add. And we can say IP address matches 10.10.11.188. Click OK. So now, wow, they changed how that works in Burpsuite. It looks pretty nice. I guess the interface has got upgraded. I just upgraded Burp so I could show you Collaborator. Let's intercept and hope I don't intercept everything, right? Okay, good. Well, we got backend fetch failed. Let's see. That was not supposed to happen. I don't know why that failed. Do it again. Okay. Let us turn intercept off. We can refresh the page. Okay. So everything looks fine. I'm not sure exactly what happened. It's doing a lot of request on this directory, like please null SDK, like some JavaScript that is including things has gone wonky. So let's just intercept one, put it in repeater, and then I can kind of explain it. So if we go to tickets and we just hit enter, this age is always going to be 0. And I'm surprised it's saying URL not found. Okay. So if there is a trailing slash, then we get URL not found. But if we just hit it, we get this. If we put something after it, so like the please, we also get the support portal. And the key thing I want to test for it is the age, because age is 0, right? And we want to find something where the age is more than 0. And if I look at the page and everything where things get loaded, let's take a look at like .javascript. Flask is known for like putting things in a static directory, and the caching server probably doesn't want to cache this tickets page because it's dynamic for the user, right? It doesn't want to leak other users' things. However, the Flask web server, everything after tickets that we put here is also going to the ticket page, right? So since it's going into the ticket page, we may be able to trick it to cache something. So I'm going to do /static, and then we'll do please subscribe. So we still see age of 0, and that's probably because this is the first time it hit this URL. And again, let's just search this. Let's search pending PR merge, right? We see it's on this page. So I'm going to make another request now that it's been a few seconds. And we see the age is 17 because this page is 17 seconds old. Make another request. I'm going to guess 26. Oh, 25. I was very close. So we can see we can force the page to cache things. Now, the other thing, it may not even need this session cookie because we're not hitting the Flask code anymore. We're hitting a saved version of this web page. The whole idea of caching is to prevent you from getting back into Flask because that's wasting CPU cycles to do things, right? It's just a static page right here. So if I refresh this without a cookie, we can see it still serves me up the page. So this is going to be a like cache deception attack is what I think it's called. But essentially, we force the web server to create a cache, and then now we can access that. And this is going to be important because if the web server is coded similarly, where like get/tickets and then anything after it for admin tickets sends you the page of admin tickets, we may be able to get the admin to click a link and then have him cache the page for us, right? So let's go back to the escalate page. And then we want to, probably doesn't matter which one of these we click because we just want the admin to click a link, right? So I'm going to do HTTP 10.10.11.188/admin_tickets. And then we'll do /static because it looks like things under the static directory get cached. And then we'll do please/subscribe. And again, this doesn't matter. It's just for caching things, right? So let's send this. And now I'm going to attempt to access this page. So we go back to Burpsuite, go admin tickets, please subscribe, and we get access denied. I probably should have waited a few seconds because now if the admin hits this, he's probably going to get cached and go to this page. We can see it's 11 seconds old. Before it was 0 seconds. So no one clicked that link. So let us give a second link. So we'll do thank you, I guess. Thank you. Click send. So we have sent that. And then we want to get thank you, but I'm going to wait 30 seconds. So I'm going to do a sleep 30 and we'll pause the video and come back when that sleep is done. Okay, it is now done. Let us hit this thank you page and we see it's been 63 seconds and we have a support portal because the admin clicked it. And it's also caching the session cookie as well. This is probably the session cookie of the admin user. We can see our session cookie begins with 9D. This one is 0CA, right? But let's just copy this so we can copy the URL and then go here and send this. And we get the admin tickets page. It also says we are logged in as admin. And also, we don't need our cookie. So we can prove that by going here, deleting our session, refreshing, and it sets our session to be admin and gives us this page. So let's try logging in with Diego and these credentials. So I'm going to SSH DIEGO. Yep. At 10.10.11.188. And we need to do yes. Paste to log in. And we get logged in. But before we look into the root, I wanted to go into this attack a bit more to make sure people understand it. And so when I forget about it, I can refer back to this video. So it is the cache deception attack. And right now I just have a request where I get slash, and it's not caching anything. We see the age is always 0, and we only see one number here. We found out that it's caching anything in a static directory, right? So if I do please subscribe.css, we see actually a new header, this cache control, public. So I'm guessing this is a public page and the max age is 240 seconds. So age was 0 because this cached it, right? So I'm going to hit it again and we have the age of 14. Cache control is still present and Varnish has 2 numbers. And these are IDs. This is so we can track it through logs. Nothing too important there. But I'm going to go on the actual server so we can look at the config. There's 2 mistakes that are made. Number 1 is the code and number 2 is in Varnish, right? So let's take a look at Varnish's config since that is what I find more interesting. We can see there's the backend default. This is probably where the server is. If we looked at the netstat, 8080 is where Flask is running. So VCL, this is like, I guess, Varnish's language. Probably Varnish control language or something, right? But we see if it returns static, return hash. Or yeah, if the URL contains static, then return. So this is why we can cache any page in static. And here's the backend response. So I'm guessing this is, if it does get a hash, then this is how it's going to respond. It adds this cache control and then returns it, right? So one mistake here is there's no like hashing at all of the user. There's 2 ways you can do a caching thing. There's probably more. I'm not an expert here, right? But generally when I set up caching things, I just want to make sure that one user is cached so they're not making repeat queries. How Varnish is configured right now, if I hit a page and you hit a page, the page that I cached is available to you. For a website that doesn't have any sensitive data or user login, it's not dynamic, that may make sense. But for something that becomes dynamic, that doesn't make sense because you never want my data to be able to be viewed by other people, right? So if we go back to our browser where I have some pages pulled up, this is the Varnish developer portal that just talks about this. If you're really curious, I would recommend reading it because it has a lot of just good information that we'll go over or that we'll use For instance, this one is removing all like Google Analytics URL things from it. If you use Google Analytics on your page and a caching server, you'd probably want to do that so you don't just fill your cache with unique things because of Google Analytics. This one blog post had something really cool on it, and this is talking about the VCL hash. So this is another function on how to determine what gets hashed. And I'm going to use the HTTP user agent, and then we'll switch over to the cookie. And the cookie is how we'll identify only I can access things that I cache, right? So I'm going to put this function in, and then we'll save it, and then restart Varnish. So service Varnish restart. And all we did was, whoops, I restarted it twice. Added the user agent to hash data. And what hash data does is it makes that like cache or identifies who can access this page. So if I go back to my please subscribe.css and we hit it, we know we have hit the cache because we added this cache control. As we see here, the backend response, it contains it, add this, right? So I'm going to refresh this, and our age is 11. It's going to go up to 240, I believe. Maybe it's going to be 1 day. I don't know what the difference between TTL and max age is. I'm going to guess it'll be live for 1 day. Or maybe 240 because we did cache this before and it's gone now. So we see it keeps going up. I'm going to change my user agent to .1, and we see we have now cached it. So I refresh again. This is 3. I'm going to go back down to 0. And we see that's at 43, 45. So now we have 2 versions of this page, but depending on the user agent, it's getting delivered to a different person, right? So this is how we be able to hash the cookie, I believe. I want to say if we do rec HTTP cookie, let's see what happens here. Save this. And then restart Varnish. Okay. Hit it. 0, 2. So I'm going to change my cookie. This C is now going to be a D. I'm going to see if my age goes to 0. It does. So now 2, 3. If I change this to C, now that's 15. So now we have 2 different versions based upon user. So that is one way we could have secured this whole caching thing, right? Is just making sure that the user that gets the dynamic page can only retrieve it. Now, the last thing is like, it's a weird problem, right? I've never paid attention enough to web servers to notice like, oh, I'm on this ticket page and I can put anything after the URL in slashes and hit the ticket page. That seems weird to me. I'm guessing I'm not logged in right now, so we probably should log in to the application. Logged in as Robert, get tickets. There we go. So hit this. And now this still gets the ticket page. So if we looked at the web code, so v diego app.py, and then we want to look at tickets. The reason why is this app.route in Flask is path. So this is letting anything after tickets hit this function. And this is just returning all tickets, right? And the admin tickets is the same way. So if you're using caching and basing it purely based upon the folder, and your web server has things like this that allow users to put folders and it doesn't matter because of just how you have configured the route, then this becomes exploitable, right? Because if this path wasn't configured this way and the admin ticket was only on / like this, then if I append the /static, then it goes to a 404 page and doesn't hit this function, right? So this is the other vulnerability. And it's only a vulnerability really when caching things come into play. So it gets very hard for automated things to detect. So hopefully this kind of cleared things up and you enjoyed it, but let's get back to pwning the box. So now that we're Diego, let's just do a sudo -l to see if we can run any programs. And it looks like we can run the ml security as root. So if we go in this op security directory, we can see there is a file, ml security. So let's do vim against it and just take a look at what it is. First, let's make sure we can't just write it and then edit it. We can't, only root has write permissions to this. We can do find.writable to see if there's anything else in this directory that we can write. There isn't. So taking a look at this, it is using TensorFlow. And TensorFlow is just like a machine learning thing. And the reason why I know TensorFlow is we see it right here. There may be other references. Nope, right there. So using the saved model CLI functionality of it. And I don't know much about machine learning, so we're just going to step through this. We have a bunch F1 to F6 variables. It's looking like it's loading models right here. And we can see model 1 is this decision tree classifier. And if we Googled each of these with TensorFlow, we'd figure out kind of what they are. So let's see, TensorFlow, build train, TensorFlow decision. Let's see, does this explain it? I don't know. It looks like it's like decision trees. So we got a few models here. It loads them all. And I'm probably going to say wrong things here because I know next to nothing about machine learning. It's getting a vector and it's looking like it's building things to detect against like cross-site scripting just because we have a bunch of things like style, layer, embed, things like that. Exec from care code, alert. So it's detecting probably XSS or cross-site scripting. So I'm guessing this is going to identify if a link is malicious just based upon everything it's importing. And again, like feature 2, feature 3, feature 4. So like feature 3 is using model 3, which is the Gaussian NB, which I don't know what that is. So we add all of those. And then it's going to grab links. So it's going to go into the database. It logs in as Diego with his password. And then it's going to select reason from escalate. And then get the vector and I guess predict if it's cross-site scripting or not. Not sure what it does that for, right? But it's got some machine learning there. So if we just do sudo -l and run this program, we can see what happens. So we'll run this. We get some error messages. Next time I run it, let's just do to dev null to hide errors because this doesn't have a GPU. And this is saying if you do not have a GPU, you can ignore this. So we get nothing. Let us go back to the support portal, http 10.10.11.188/test. And then this will be a, whoops, did not mean to capitalize it. href is equal to http 10.10.14.8. Click me. So I guess if we run it again, we'll see if it outputs any numbers or anything. It doesn't. So let's do XSS payload on Google and get an example payload or payload all the things. So let's see what happens if we give it some cross-site scripting. Oh, come on. I thought Google would bring me to the spot I wanted. Angular, path overwrite. Let's just do images. No? Let's see. Scroll down. Script. Let's do, sure, this. See what happens if we put this in. Send. I'm guessing that's sent. Go here. And still nothing. Let's see, is there another payload we can use? try this one. Go back here, paste. I'm going to do Burpsuite. So this time we can verify it's actually getting sent. Looks like it is. And I'm guessing the script doesn't really do anything, or I just don't know how to use it. If we looked at vulnerabilities, so let's just do CVE TensorFlow to see if TensorFlow itself has any vulnerabilities. So CVE details, we see there are quite a few vulnerabilities in TensorFlow. So let's identify how we get the version. So TensorFlow version. Let's see, get version. How to check TensorFlow version. This looks good. So we import and then print. Okay. So let's do Python 3, import, print, and we're version 2.6.3. So let us Google TensorFlow version 2.6.3 exploit, I guess. And we do have some things. And this one looked interesting, the GitHub advisory code injection. And it looks like the save model CLI, if it's input, exec, and then we can just import things. I think that's what it's saying. And it looks like it's because it's doing the input raw, which in Python 2 is like just running input, right? We can just get straight code execution in exec statements. So let's try this. So let's just do, let's see, go back to the page, support portal, okay. So we can do test is equal to exec, and then it used 3 quotes. Yep, so 3 quotes, and then \n for line breaks. Let's close some of these links or pages. There we go. One, two, three. And let's just do import OS. Why is that? That O always seems to be capitalized. I guess this is a weird font that it's using. No? I have no idea what's going on there. We'll fix it in Burpsuite. os.system bin sh. So let's try this. \n, 1, 2, 3. Does it just terminate after I close the page that we wanted? Let's see. Let's just put a XSS filter or payload. So we can do script and then alert. And based upon the source code of the app, I think this should get just flagged as XSS. We need to turn intercept on, so I make sure this O is not capital. Let's see. Import. Yeah, that O is not capital. That is, I have no idea what's going on there. So test exec import OS, os.system bin sh. Yeah, that looks fine. So let's send this. And then run sudo and see what happens. Oh, we have a shell. So I can just do, I guess the prompt is not working. If I do exit, it exits out. But I bet if we did bin bash, we'd probably get a shell. So it stopped. I wonder if it has a timeout. Run it again. So we can run code as root. So if I just do this and we can cat root.text, maybe we should well, it was working. Run that again. There we go. So I'm guessing there's some timeout that is preventing us, right? But we could like make bash set UID or do something, but we're clearly root on this box from exploiting whatever CVE that was from TensorFlow 2.6.3. So hope you guys enjoyed the video. Take care, and I will see you all next time.